All right, today we're going to be talking about domain and range. So one thing I want you guys to write in your journals. All right, you've drawn this picture. Great job. Next thing we're going to do is we're going to label the domain and the range. All right, so first thing I want you guys to do is we're going to talk about the domain. So if you guys would, write the word domain. The domain is dealing with the set of all of your x values that are in a function or in a graph or in a relation. All right, so the set of all the x values. And a lot of times they'll put this set symbol. This is what the set symbol will look like for the domain. Now just remember, the domain is talking about your x values, and your x values always run left to right. So when you're talking about the domain, make sure you put x always from left to right. Like how far does it go to the left? How far does it go to the right? Now there's different types of notations. You're probably used to seeing inequality notation, but we're going to be talking about set builder and interval notation as well. But right now, to start that, let's talk about the minimum value for x that we see and the maximum value for x that we see. So this graph that we see right here is a continuous graph from here, and then eventually it stops here. So let's take a look at this ordered pair. What would you guys say where this open circle is? What is that ordered pair? All right, if this right here, if this is 0, 0, there's the origin right there. Okay, looks like we go over 1, 2, 3, 4. Yeah, so we're going to put -4, +2. So if you would, go and label that, put -4, +2. And then this graph continues to go all the way over to right here. And we're going to call that point 1, 2, 3, 4, 4, 3. So right here, I'm just going to put 4, 3. Now, the domain, remember, the domain is dealing with the set of all of your x values. So our x values run from -4 to +4. So the minimum value for x, the smallest value for x that's graphed is -4, but the maximum value that's graphed is +4. Now, this is called continuous because it's not just a bunch of random points being plotted. So if I were just to plot points like this, we don't call that continuous. We call that discrete. All right, this would be a discrete function. So if it's just dots, it's discrete. But if you actually have to hold your pencil or pen on a graph to trace it, that is what's referred to. I'm going to put a little arrow. This is called continuous. All right, so this is considered to be continuous. This is considered to be what's called discrete. So because it's continuous, all of my x values are between these 2 points. But we don't, when we say between, we don't do this. We don't like draw, okay, all of my x values go that way to that way. We don't do that, okay? So there's inequality symbols that we're going to put in here. So all of my x values are less than or equal to 4, but just greater than a -4. Now, how do I know to put an equal to sign? This is very important. This equal to sign is because we have a solid dot right here. This one has an open, it's not closed in, and so when we have an open circle here and it's not closed in, you're not going to put the equal to sign. So make sure you understand the reason why I'm putting equal to is because that's solid. The reason I'm not putting equal to is because that's open. So what does that mean? It's like it's approaching -4, but it doesn't quite get there. Just like that annoying kid in your elementary school class that kept saying, "I'm not touching you, I'm not touching you." All right, and they get really, 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 really close, but they really don't touch you, but you can feel how close they are. That's what this annoying open circle is, all right? Closed circle is what you want to do to them, like you want your fist to be right there on their nose, okay? Like it's including it, all right? I'm not condoning violence, though, okay? Not condoning violence. All right, so what we just wrote, everybody, what we just wrote, this part, I'm just going to put right over here. This section right there, that piece. That's what we call an inequality notation. Basically, that's just the inequality that matches the domain. So I'm going to write, that's what's called an inequality. What we're going to do now is we're going to take that inequality and we're going to put it into a set. And we're going to call this set builder notation. set builder notation. And what I'm going to do is I'm going to use words to describe what's happening. So I'm also going to build the set. So I'm going to put the set of all x values such that all of my x values are less than or equal to 4, but they are all greater than a negative 4, and I'm going to close the set. So this is called set builder notation. You'll notice, hopefully you notice, that all I did was take the inequality that I built right here. There's the inequality. And I simply took that inequality and I placed that inequality right there into the set. So there we have, there's set builder notation. Now, what does this part mean? This part means the set of all x values. That's what that means, the set of all x values. This little vertical line, all right, that little vertical line means such that. Now sometimes set builder notation, and by the way, that's you're done with set builder notation. So I'm going to put a little box around it. That is set builder notation. Sometimes the vertical line, they use a colon instead. Not very often, but sometimes you'll see this. The set of all x values such that x is less than or equal to 4, but greater than a negative 4. So sometimes you might see it as a colon, but these mean, what does that little colon also mean? It means such that. Okay? So the vertical line means such that, and the colon right there means such that. But these are both technically in what's called what type of notation? Set builder notation. Okay, the last notation we're going to talk about is interval notation, and this is the easiest of all the notations. So right over here, I'm going to write, right here, I'm going to write interval. So if you would write interval notation. And interval notation is the easiest, I think, the easiest notation to build and to write. So basically, it's saying what interval between what x values are being plotted on the graph. And we already know those x values, all the x values between negative 4 and positive 4. So it's very easy. All we do is put negative 4 to positive 4. But there's a couple of symbols you need to know. One of them is going to be what's called a soft bracket, and one of them is going to be a hard bracket. Now, a hard bracket means equal to, like it's including the number, all right? So in an inequality symbol, you have the less than or equal to. In interval notation, you just put a hard bracket. Whereas this soft bracket means not equal to. Not equal to. So here we don't have the equal to symbol in the set builder notation. In interval notation, you just put a soft bracket. And so there's your domain in interval notation. It goes from negative 4 to positive 4. And you can see right over here, it goes from negative 4, but it's not including the number, and it goes to positive 4, and it is including the number. And there's your interval notation for this, and for the domain. Okay? Now what we're going to do is we're going to talk about the range. So I'm going to clear it out. And now we're not going to talk about the domain. We're going to talk about the range of the graph. All right? And so when it's asking about the range, what's it referring to? It's referring to the up and the down. Just remember, range deals with how high does it go, how low does it go. So basically, you read it from bottom to top. What's the minimum? What's the maximum? So remember, range is dealing with your y values. All right, so what I'd like us to take a look at is we need to take a look at what is the minimum, what's the lowest point on this graph, and what is the maximum. So let's take a look at the lowest point. Right here, you can kind of see it bottoms out right here. So I'm going to look at this point right here. That's where it bottoms out. And then I'm going to look at this point right here, and that's its max. So if you want to, you could put, hey, this is its minimum right here, and this is its maximum for the range. And this ordered pair is at -2, -1. So put -2, -1. And then over here, we're at 1, 2, 1, 2, 3, 4, 5. This is at a 2 and a 6. So what I'm saying is, remember, your y values are, it goes from -1 all the way up to a what? +6. So for the minimum, put -1. For the maximum, put +6. So all of my y values are less than or equal to a +6, but they are greater than or equal to a -1. And if you're wondering, wait a second, why is he putting equal signs here? Because if it's including the point, if it passes through that ordered pair, that means it's including the point. So you didn't have to worry about being an open or a closed end, because it actually went through the point -2, -1, and it actually went through the point 2, 6. So this right here, this is what's called inequality notation. All right, so just in the form of an inequality. Now, how do I make that into what's called set builder notation? Do you guys see how it says h of x right here? Y equals h of x. So if I wanted to write that, another way of writing it is you would literally put h of x in for y. So what I need you guys to see is this. I need you guys to see that these two right here, these mean the exact same inequality. Because what does h of x mean? H of x means my y values. All right, so now what we're going to do is we're going to build set builder notation. So I'm just going to go this way. Instead of down, I'll go this way. Set builder. The only difference between inequality notation and set builder notation is just how you write it, like how you start it. So I'm going to put the set of all y values. Okay, such that, or I could put the set of all y values known as h of x, such that. That's supposed to be like a vertical bar, all right? Such that all of my y values are less than or equal to 6 and greater than or equal to -1, and then I close it. The set of all of my y values, just known as h of x, such that h of x is less than or equal to a 6, but greater than or equal to -1. And that's how you write. That's a horrible looking bracket. Let's see if I do a better job here. There we go. This right here, these mean the exact same. These just happen to be in set builder notation. All right, so if you're wondering, like, what's an easy way to remember how to build set builder notation? Here's what I would do. Just make a little template, okay? Let's make a template together. Now, I don't know whether it's going to be h of x, f of x, whatever. I'm just going to put f of x for my y, because usually you'll see a lot of f of x. Then I'm going to put a line, a vertical line right here, which means such that. So here's what I want you to do. All you got to do is put like a box. Just put a box right here. And that's going to, what are you going to do? You're going to put your smallest values. Put your minimum value there. All right. Now, I don't know whether it's going to be less than or equal. I'm not sure which one it's going to be, but it's going to be, that's where you're going to have to choose whether there should be an equal to sign or not at some point. And then you put another box. All right. We'll put maximum. And then you just close it. So here's kind of a template that you guys could use when you're trying to use set builder notation, when you're dealing with the smallest to the highest. Now, like I said, I'm not, sometimes these might have to be not equal to, because if it doesn't include the number. So that's what you got to be careful of. All right, but there's a template for that. Now, the last thing we're going to do is we're going to write right here, we're going to write interval notation. Interval notation is very, very, very easy. All you do is you put the minimum and then you put the maximum. Well, we already know our minimum. We can take a look at our minimum right here. Our minimum is -1. Our maximum is +6. And because it passes through this point, and it passes through this point, I know they are going to be equal to. So we put hard bracket and hard bracket. And this is how you write interval notation. So we have set builder notation and we have interval notation for the domain and the range. All right. So at this point, if you've taken these notes, all I want you to do is we're going to do one more problem together, but you don't have to write this down unless you really want to. I'm going to a different page, and what we're going to do right now is we're going to take a look at this right now. I'm going to zoom in just a little bit, so you guys can see it, and we're going to take a look at this picture. All right, now if you want to write this down, you can, but we're not going to. All we're going to do is look at this, and we're going to evaluate a couple of things. We're going to evaluate the domain, and we're going to do this in interval notation. And then we're going to do the range in interval notation. Okay? So let's take a look at this. What is my x value from here to here? It looks like I'm going from -8 to 4. Because we're not including that, I'm going to say we're going from -8 to -4, but this is an open circle. So if that's open circle, it's going to be a soft bracket. If it's including it, it's going to be a hard. So this section right here, everybody, the section that goes from here to here, this is how you would write that section in interval notation. How do I write the next section in interval notation? I'm going from -2 to +4. So I'm going to go from -2 to +4. Okay? And then, since I'm going to +4, it's including +4. Well, wait a second. It's including that number, but 4 is not including it. So you'll notice right here, it actually continues. So since it actually doesn't stop at 4, it continues on from 4, I actually get to do this. I actually get to say it goes forever to infinity. Now, how do I combine those? You have to put a symbol called a union symbol. So I got to do a union symbol. So this is my domain in interval notation. It starts at -8, but it doesn't include it. So that's why it's soft. It goes to -4. Then it jumps right over here to -2, but it's not including it. It goes to +4, and it is including it. But then I realize, oh, it continues to go on forever. So that's why I say it has to go to infinity. When we are writing the range, we're looking at how far down, how low does it go, and where is it, how high up does it go. So this is the most important part for the range. Because technically, no matter what, this is going to continue to go up. This little arrow right here lets you know it's actually going up forever, which means it's actually continuing to go up no matter what. So all of these points right here of the range are already included in this section of the graph. So if we were going to write the range in interval notation, we would put soft bracket, because the lowest point it gets is at -6, that's a soft bracket, and it goes up forever to infinity. So this would be the range in interval notation. Okay? So what we're going to do right now is we're going to go ahead and jump on the Khan Academy and let you guys know how easy it is in the Khan. It's not going to have interval notation, but it will have some set builder, or actually have inequality notation on the Khan Academy. So right here, what's it asking for on this problem? It says, what is the what? What is the range? Now, do you guys see how there's just different points? These different points means it's discrete. It's not continuous. So what is the range right there? What y value is at that point right there? -4. What's the y value there? -2. This one's at a 2. This one's at a 4. This one's at a 6. That's why, there you go. This was just the values of the y value. So you'll notice it didn't use an inequality. It didn't use an inequality because they're dots. So let's take a look at this one. Would you guys consider this continuous or discrete? What would you guys say? Continuous. It's continuous because if I traced it, I'd have to keep my pencil or pen on the graph. I'm not going from dot to dot. It says what's the what? What's the range? So when you're looking for the range, you're looking for how low does it go and how high does it fly. How low does it go, everybody? -3, you're right, -3. All right, so it goes all the way down to -3. I'm not worried about the x value. I'm looking for the what? I'm looking for the range, and it goes all the way up to a what? +7. Now, it's including all the y values. So all of my y values are less than or equal to 7 and greater than or equal to -3. So that's what I'm looking for. I'm looking for all the values. And look, what did I say sometimes they're going to use? Function notation. So what does f of x mean? It means y. So there's your max, and there's your minimum right there. Very easy. Okay? Here's another function. What's it asking for on this one? It's asking for the domain. So now the domain deals with what? The left and the right. So how far to the left does it go? -5. How far to the right does it go? What would you guys say? What's the max? Correct. Max is 6. What's the minimum? -5. And all of my x values are less than or equal to this and greater than or equal to. Now, why am I saying equal to? How do I know they're equal to? Because we have what? They're closed in. So this is what I'm looking for. I'm looking for everything in between. We're going -5 and 6. This one right here. Okay, let's take a look at this one. What's the range? So what's the range dealing with? How high up and how low does it go? Right there. How high up does it fly? Right there. So this is the last one I'm going to do because you should be able to do this after it. What's my lowest point, everybody? -9. What's my maximum? -2. This says, what's the range of f? So all of my f of x, all of my y values are less than or equal to -2, but greater than or equal to -9. And that's my range. Okay, so it's either going to be asking you for domain or range. So it goes all the way down to -9 and all the way up to -2. All right, so that's basically, I'm letting you guys know this is going to be easy. We're going to have some more difficult things dealing with interval notation, and that's why we did all of the notes dealing with more complicated graphs. Y'all have a good day.